Hello students, welcome to Princeton Community Middle School's Robotics Remote Learning Program. This is week number 8 during our time of remote learning. This lesson is being prepared and uploaded on Tuesday, May 12th. This is the only video that we'll have this week, and I think it's the 11th video we've had altogether. As we've done in the past, we're going to take a look at our PowerPoint like we normally would do in class. Our past due assignments are listed here. Weeks 1, 2, and 3, we had both a written type of assignment and a project type of assignment for those 3 weeks. Weeks 4, 5, and 6, or weeks 4 and 5, we had a written assignment and a project each of those weeks. Starting with week 6, we just had one assignment, and it was a worksheet on the history of timekeeping. And then last week, I assigned the timepiece project. It's due this coming Friday, so you've still got plenty of time to get it done. If you need examples or ideas, you can watch the last video, the video for week number 7, and you'll see 4 different examples that I made. A few of you have turned it in, but don't be in a hurry because it's not due until Friday. Everything that's been due so far can still be turned in for full credit. Also, you're allowed to resubmit work. So if you got a low grade on a worksheet, turn it in, redo it, and turn it in again. Announcements, we have a Zoom meeting every Wednesday, so I'll be available for that tomorrow. If you'd like to have one-on-one help, especially with things like measuring, request an appointment for a time on Thursday, and I'll arrange a time to meet with you on Zoom, and I can use a second camera to explain to you on paper how to do things, and that's the way I would probably explain how to do measurements. Also, opportunity to resubmit worksheets and projects, which I said just a minute ago. Everyone should be scoring 100% on these worksheets. You've got a worksheet, and then you've got the resource sheet right next to it. So unless you don't understand the question, you should be getting all of the questions correct. And if you don't understand a question, you can ask your parents, you can email me, or ask a classmate, and hopefully they can explain it to you. I haven't had anybody tell me they didn't understand a question, but I can understand if you don't. Just let me know if you need some help. Our weekly schedule, I'm emailing updates every Monday and Friday. Last week, if you only got one email, that's because the second email only went out to students that were behind on work, and that email also went to parents to keep parents apprised. Tuesday, today, we'll have the lesson, and then Wednesday and Thursday, there's times available for Zoom meetings. Today, our topic is going to be simple machines, and we'll be doing some work, a worksheet on this this week, and then you'll have a project related to the simple machines next week. Simple machines are simply things that make work easier, and you've probably studied this in science class. The difference between science class and our class is we're going to apply what you learned to some type of a practical situation, and that will be next week. So you've probably learned there's things such as a lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. If you look up simple machines on the internet, probably 95% or better will have these 6 categories of machines. In a few cases, they've combined a couple of these machines together, and they whittled it down to only 3 categories. And in some cases, I've seen people, instead of putting down the wheel and axle, they'll put down gears and pinions. But well above 95% will have these 6 categories of simple machines. Most people think of complex technical or electronic gadgets with motors when they hear the word machine, but machines can be much simpler. A machine is any device that lets you do work in an easier or better way. Basically, simple machines make work easier. So if your task was to run a mile, it gets pretty tough unless you're used to that. But if you got on a bicycle, it would be a machine that would help you cover that distance easier. How do machines work? Machines make work easier by changing 3 things about the force you exert to do work. It could be the amount of force you exert. So you could be using less force to accomplish a task instead of more. The distance over which you exert force. So in other words, it may be a much longer distance that you have to travel to make something easier. And then the direction in which you exert the force. A machine can cause that machine to be Instead of rotary, it could be in a straight line or vice versa. So the direction can be changed. What are simple machines? There are only 6 basic simple machines that make work easier. And I just mentioned those on the introductory slide: incline plane, wedge, screw, lever, wheel and axle, and the pulley. And there's pictures over here that are examples. All the things that I'm showing you here will be available to you on the resource materials in Google Classroom. Work in simple machines. Simple machines don't change the amount of work done, they change the size, distance, or direction of your force. So that's important. It doesn't change the amount of work done. So for example, I told you guys that I rode my bicycle across the country several years ago. When I was in the Rocky Mountains, I had to go over these mountain ranges that were 9, 10, and 11,000 feet high on a bicycle. Now, if I had tried to go straight up 11,000 feet with a bicycle and all my luggage, that would have been impossible. But because I was able to go up gradually, like an inclined plane, it may have taken me hours to do, but it was much easier than if I was trying to do the impossible task of going straight up 11,000 feet. So the work being done is the same, but the way it's done is what's different. In red letters, it says work in equals work out. Now, it's a little bit deceiving. Theoretically, work in should be work out, but there's a little asterisk. It says the workout is not perfectly equal to the work in because a bit of energy is lost due to friction. Friction occurs when objects rub against each other, causing machines to slow down and get warm. So when I was pedaling my bicycle, there was a little bit of resistance in the chain and the sprocket that it went on. There was also a little bit of resistance in the axles. It was friction causing a little bit of heat, and it made so it took a little bit more energy to go further. Also on the tires, the more they're blown up, the higher the inflation, the easier it is to roll. So if my tires were low, that causes some friction against the road and slows you down. So work in, work out is theoretically true, but in reality, you have to deal with friction. Inclined plane is the first simple machine we're looking at. It says an inclined plane is a flat sloped surface. It connects a lower level to a higher level. You use less force over a longer distance to raise a load to a higher level. So this is what I was telling you about on my bicycle trip. Instead of going straight up, I was able to spread the workout over a longer distance. Here are some examples. Ramps such as a boat ramp or a wheelchair ramp. And even though it's not a flat surface, down here on the lower right, it says ladders and stairs are another example of an inclined plane. Another machine is the lever. A lever is a bar that pivots or rotates on a point called a fulcrum. Levers may change the size, distance, or the direction of the force. The fulcrum is the pivot point. Down here in the lower left-hand corner, the little red triangle is the fulcrum. That fulcrum can be in the middle, like on a teeter-totter. It could be out here on the end, and you could be lifting at the opposite end, or the fulcrum could be on the end, and you're lifting from the middle. So those are called first, second, and third class levers. Examples of these: first class levers would be scissors, seesaws, and pliers. That's where the fulcrum's in the middle. And you have an example here with a pair of pliers. Second class lever: staplers, nutcrackers, and wheelbarrows. And you can see here the fulcrum is at the end, and your effort is on the opposite end with the load in the middle. And then third class levers: shovels, baseball bats, tweezers. So you can see here the fulcrum would be the hand, the loads out at this end, and the efforts at this end. And the tweezers are the same way. You know what? I told you that wrong. The fulcrum would be this hand, your efforts in the middle, and then the loads at this end. Tweezers, the fulcrums here at the handle. Your effort would be where you squeeze them, and the load would be on the end. Pulley. A pulley is a grooved wheel with a rope used to raise, lower, or move a load. Pulley systems change the direction and or decrease the input force so you can move heavier loads. So when you're lifting with one pulley, you have to pull down as hard as it takes to pull something straight up. If you use two pulleys, you have to pull the rope over a longer part of the rope, but it cuts the effort in half. So like I've seen people lift engines out of cars, and they're able to use several pulleys in a row. And every time they add a pulley, it cuts the amount of force required to lift that engine. So the engine could weigh several hundred pounds, and the person pulling the rope only weighs 100 pounds, but by using pulleys, they're able to lift a larger load. Examples are cranes, raising a flag on a pole, window blinds, raising a sail on a boat, or even a clothesline. So these are all examples of where pulleys are used. Wedge. A wedge has slanting sides that meet at the edge. It splits materials apart. It changes the force in one direction to a splitting force that acts at right angles to the blade. So you'll notice here the red arrow is the input force going straight down, and then the green arrows, it's moving the force to the left and the right. So you're pushing down, but the force is going to the side. Examples, axe, knife, and even zippers. It's used in all cutting machines to split materials apart. So you've got the axe up here, the zipper in the middle, and then you've got the knives and carving tools. Wheel and axle. The wheel is locked to the central axle when one turns, so does the other. A short, powerful force at the axle will move the wheel's edge a long distance. A long motion at edge of wheel moves the axles with great force. So in this case, the axle is firmly attached to the wheel. So if you turn the axle, the wheel turns with it. The axle is the long, small part attached to the wheel. The wheel would be the large, round part. Examples, screwdriver, windmill, cars and bicycles, a rolling pin that you cook with, doorknobs, and fans. So those are all examples of wheel and axle. Screw. This is another machine. A screw has a thread or groove wrapped around a central cylinder. So in this picture, these little lines, those represent the threads. While turning it, it converts a twisting force into a forward or backwards force. So you're turning it this side where the handle is, and the output force is the screw going into the wood. Examples, screws can hold things together or lift materials. So this is called a bolt and a nut, and you could put two pieces of material in the middle and tighten the bolt and the nut down, and it pulls them together. Or another example is the lid on a jar. It pulls it down tight when you turn it. Screws, obviously that would be an example. Screw top lids for jars and bottles. The light bulb with the little threads down here at the bottom of the socket. And swivel stools and chairs, the type that you would turn a bunch of times and it raises the seat up. So a review of these, let's take a look at this. What is this one? And they show an example of it being used. In this case, it's spread the force to raise that box over a longer distance. So this is called an inclined plane. The one on the right, this is the axle attached to the wheel. So this is a wheel and axle, and the doorknob is the example. The next one down, second one down on the left side, this is the one that wedges, like in this example, wedges between the wood to push the motion straight down to either side. This one we just talked about, it's got the threads on it, also on the lid. This would be the screw, and it pulls things together. This is a lever, teeter-totter. And if you push down one side, the other side goes up. An example of that being used would be the claw on a hammer, a claw hammer, used to take nails out of the wood. And both of these are examples of a pulley. By pulling down, it might be easier for you to put your weight into it. That lifts the bucket up more. By using a pulley at the bottom and the top, you're able to raise the flag. And by using several pulleys, you can cut down the amount of force needed to lift something up. So those are all, that's the material that you'll see on the resource packet. It says this week's activity is to answer the questions on the Simple Machines worksheet. All of the answers are reviewed in today's lesson and are available on the Simple Machines resource slide. I think I just said packet, I meant slide. Everyone should be getting 100 on this. You look at the question, look for the answer on the resource slides, and the slides are the same things as you just saw, and then put down the correct answer. I still have students turning in papers with 10s and 20s and 30s. And according to their parents, the students never looked at the resource answers. So they've had to go back and redo them or else take a low grade. So this assignment is pretty easy. Today's assignment is due at the end of this week. That gives you 3 good days to turn it in. And if it's turned in late, it still counts for full credit. It just says, it just shows up as missing on progress book. So I think that's all I've got to cover. Yep, it is. So until next time, which will be next Tuesdays when I'll have another lesson for you. Continue to stay safe. I know we have stores opening up this week. My hair is getting really long and I need to get in and get my hair cut. Those places are opening on Friday. So we got some good news, and hopefully we don't all get sick from this. Hopefully things go well and we continue to open up the country and the rest of the world. So until next time, stay safe. Bye.